Okay, so we are here tonight again. So, how was our experience last night? Are we able to try something on our own, like look into that particular thing I talks about sound segment display, being able to generate those code and fix that particular. I think number two that was not correct. Shay, are we able to do something like that last night? Hello. Okay, can we hear me? Hello. Hello.
Yes, I hear you.
Hello, sir. Can you hear you, sir? I'm trying to
Okay.
sort out something.
I said, can we? Did we actually try it and fix what was the challenge, or should we just look into it today again? Then we make progress from there.
I think we should go over it again on Ultimate today so you can stick.
Okay.
So anything we learned yesterday can
Okay.
so we can just move forward.
All right. It will. Definitely it will. Okay. I will do it. No problem. Okay. I start yesterday class by starting with the fact that we humans we take advantage of our sight more than our audio. We take visual more than audio. It has been proven from research that about 70% of information that brain uses to make decisions comes from the eyes. So the eyes becomes very very important sense organs that gives information. And I say for we in electronics world, we one of the things we are trying to do is to ensure that this um, information visual we capture it as much as possible, and that's the reason why we have different type of screens, different kind of upgrade technology improvement that is happening currently on visuals. So I said that the game towards visual actually started from LED, then from LED moved to seven segment display. And I said seven segment displays like we have seven LED diode LED that was arranged in a particular format that forms seven segment. Okay, seven segment. So let me so we use this to display informations to people in numbers in series. A little observation shows that the maximum numbers of things you can display using seven segment is 2 raised to power 7 minus 1. That's, I believe that should be 127. So these are the number of possible combinations you can have that will make sense, because you can't actually have one LED to give you something that makes sense. Okay, let me share my screen so that we can begin from there tonight. Entire screen, then this, then share. So from it's still not yet up. Yes, yes, I have my screen now, I believe. Okay, so going back to what we talked about yesterday, and I said there is two basic configurations of this LED based on the arrangement of the diode inside. There's one called the common positive or the common negative. So in the common negative, now all the negatives are joined together. Then you are expected to feed in positive signals to turn on the LEDs, individual LEDs, corresponding LEDs. While in the other hand, there's the common negative ones that you are supposed to the common positive ones, you are supposed to feed in negative signals in order to be able to generate them. So this one turns it on, this other one's zero turns it on. It's just like that format. That so it's very very common that you find people using common negative so that you can just keep feeding the positive, I which tallies with the logic we are aware of. Now using that particular stuff, we moved further and we said that
Sorry, you.
okay.
Sorry. For the common negative, one turns it on, right?
So for the common negative, all you have to do is to send positive signals there. Look at this symbol
Uh,
now is a symbol of common negative. So I think let me even open this particular stuff. Things that I need, I think is plenty. Okay, this should also be a very, very good. Open this. This should also be a very, very good link to look into. So, common negative one now, it means that all the negative of those, now the way you need to see it is that all these LEDs are individuals. She understand that they were not internally connected the way you are seeing it like this. So it's possible to imagine them that they were 7 LEDs that was connected like that to form this, but in our case, those ones that have decimal points now, they will be 8 LEDs. So the negative of all these LEDs were being connected together. Let me do something like that on Pro Tools so that I can still bring without Pro Tools 8.0, so it can be a bit far more better, more clearer than what we have currently. This is coming on, so let me just do common positive and common negative. So don't remember what we did on Bitwise yesterday. Okay, for this one now you can see that all the negative are being connected together, all the negative of individual LEDs. Same here also. I believe this just explains it better. So why? Okay. Same here also. Okay. This was the image.
I can't see what you're showing us. What are you showing?
Okay. My screen is not
What are you
showing.
showing us?
My screen is not showing. My screen is showing now. I believe so.
It's showing, but I can't see what you're pointing at. What are you pointing out?
Can you see my
That's
cursor now?
common.
It's not showing my cursor.
You can see it now.
Okay. So can you see this?
Wait.
Can you see this image?
I can see the cursor. What are you pointing at?
Now this image that has this. Let me show you now. This particular image now.
Yeah.
So this is the common anode ones. You see, I believe you know that this direction is the positive side of a diode. The place where the arrow starts from is the positive side of a diode. Let me see this. Let's start a new project here so I can bring more light here.
You're showing us Pro Tools. You're
Yes,
showing us Pro Tools now.
yes, I want to still do it on Pro Tools so that you can see it. Now, if you are looking at the diode, can you see this is a symbol of a diode? Can you see my cursor now? Can you see my arrow now from here? Is it showing? Hello? Are we together?
Mm-hmm.
So this is a symbol of a diode. Let me
Yes.
so that there won't be anything here. This is a symbol of a diode. So this particular diode, this particular case now, this place where the arrow is pointing from is the positive side. Where you have this flat,
you can't hear me.
What?
I said yes, you can see what I can see.
This flat part, this flat that looks like a line is the negative part of a diode. So imagine that this is diode A, B, C, D, E, F, G, and DP. Now like this. So if you connect all the positive together like this, then you have common anode. Can you see? Common anode. So for you to turn on this A now, what did you have to put here? You have to put a negative here because it already has what? It already has a positive. for this circuit to be complete, you need to put a negative here. Did you get it now? Which is 0. Is it clear now? But for this one, in this place, common cathode, all the negative are connected together. Then what you have to do is to put what? Okay, look at this symbol now. This place is called anode. This place is called cathode. This is the positive side. This is the negative side. Now, irrespective of whether you connect all the positive together, you will need individual negative to on each of them. If you connect all the negative together, you will need individual positive to on all of them. Is it clear like that? Hello? Is it clear? Hello? Hello? Hello?
Yes, clear.
All right, good. So,
It's clear.
all right, thank you. So we can go to this place.
Yes, sir. I hear you.
All right, is it the network that is now playing now? New. Let me just do new, just like that, and I'll still do it here.
But can you hear me at all? Can you hear me?
Yes, I can hear you now. I can hear you now.
Can you hear me? Can you
Yes.
hear me, Isaac?
I can hear you. I can hear you. Can you hear me?
Or is
I
it
can-
lagging?
I can hear you. Uchi, I'm hearing
Okay.
you. I'm hearing you. So,
Okay, it's fine.
so before I wasn't getting response. That was why I was just. So let Pro Tools come in. So we can decide to use any of the configurations, but you know that this is now programming. Did you get it now? That what turns this guy on is what turns this guy off. So you just have to be so sure before you start. So let me do something. I believe this place is feasible. I believe this place is feasible. So what I want to just do here is to okay. Okay. I need jumper wires. So let me just use one female to female and one female to male. Okay. I just want to demonstrate that in real life, what I just explained now, in a real life scenario. So, can you see my camera? So this is a 7-segment display, for example, this one. But this particular one now, that's okay. Let me also be on this page on mine so that this recording can capture it also. So this had 4 digits. Can you see? 1, 2, 3, 4. So, and you will have expected to have what? 4 times 8. That's 32 pins. Is it not true? But it doesn't have 32 pins. It will only have 12 pins, peradventure, or 13 pins. So this is 12 pins because it is multiplexed inside internally. So which we are going to get into during the course of this our class. Now if you remember this my board when I was using it to train, there is a place where there is positive voltage here and there is a place where there is negative voltage. So since I know those locations, so all I have to do is I want to believe that this place should be positive. Okay, I can also confirm that from my multimeter. So I don't just stress myself. So I plug in the programmer to my system like this. Then I move to voltage. So I'm on voltage level now. So what am I looking for? I'm just looking for 2 pins that will give me 5 volts. So I've been able to get where my positive were and where my negatives are. So I'm going to take two wires now. One to take negative out. So what can I call what I'm doing now? I can call what I'm doing now is actually detecting the pins of a 7-segment display. So if I pick one 7-segment display like this, for let me use the single one. This one is the single one. So what I would need to do is, this is a common negative. If I fix it to one of these ends and I move the positive around, so I have nothing turned on. Then I will move like this. See, I have, okay, that's removed. So I'm just going to try the 4 extreme conditions, like the 4 extreme situations.
So are you using phone camera?
Yes, I'm using phone camera.
Isaac.
Yes, I'm using phone camera. Can you hear me? Hello?
Hello.
Hello?
Hello, sir. I think you should make that tile for everyone. Pin that tile, sir, so we can see what you're doing.
I should bring.
Using phone camera. It is like.
Yes, I'm using phone camera.
Because we cannot see the segment.
I think you. Are you?
Hello.
Can you see it now?
I think you should pin the tile. Pin that tile you are using there, the camera you are using.
Yeah. Pin potential innovation. Pin it.
Okay. All right. I should make it big.
It's very small. It's on the side.
Yeah, you have to stop sharing first. Then,
okay, I should stop
pin that tile. Then you can.
Good. Thank you. We are learning day by day. Thank you. Stop sharing.
Then you pin this tile for everyone.
Okay.
Yeah, pin this tile. This yes, stop. You cannot pin this.
Potential being. Pin for
yes,
everyone.
pin the potential for everyone, so everybody can now.
So will it be bigger for everybody now? Is it okay now?
It should. It should. Yes. But you haven't to. Okay.
Yeah, it's better now.
Yeah, we can have a better view now.
Okay, it's fine now, Shay. Thank you.
Oh, you have a
I've
better
been
view
thinking
now.
of how did they used to do this thing seriously, and I did not know. All right, let me start again. There are 2 ways to this.
Yeah, thank you.
There are 2 ways to this. One, you can actually go online, she understand, and when you are ordering your 7-segment display, you have to specify. You will find that specifications here that what I'm looking for is the one that is common cathode, or the one I'm looking for is the common anode. She understand. So I was trying to explain something that now, because there are different versions of 7-segment, you can see this one with me here. You can see this one with me here. This is 1. This one is 4. So I believe I still have another one here that is 2. So this one here is 2. Can you see? So Nigerian market is a kind of market that if you just go and you buy 7-segment like this, you might not have any details to it, that okay, whether these are the pins that is useful there. Like, this is where A is, this is where B is, this is where C is, this is where D is. Did you get what I'm trying to explain tonight now? But eventually you are not, you don't have access to that information. You understand? Beforehand now, you don't know where your positives are, where your negatives are. How will I be able to detect them physically? Did you understand the aim of what I'm trying to do now? Is it clear?
Yeah.
So, but most likely, if you order from online, you will know what these pins were. they will specify it, which I'm still going to show you online how to get them online, because I order all these ones from AliExpress, all these four type from AliExpress. Okay, so that being said, now I now said for me to do this test I need positive 5 volts, 5 volts and negative and ground. Sure you get. So I really want to take that 5 volts from and ground from my USB, I mean from my laptop, and that's why I plug USB AV programmer to this board. Remember, if you remember something about this board, that it has a VCC and also have a ground. Remember that time that I showed you something about ICSP pins. When we look at MOSI, MISO, reset, we see something like VCC and ground, which are what? Which are positive 5 volts and negative 5 volts. So I now say, if you take your multimeter and you turn your multimeter to voltage, this is DC voltage, and I'm on 20 now. Like that's the maximum range that you can get from this particular point. So I just trace all those pins and I find out that my positive is somewhere here. Just look at it. My positive is somewhere here. And remember, if you still, can you see? I'm having 4.93. 4.93. So where I am currently is the positive. So peradventure you miss the probe like this. Look at what will happen. You see, it says negative 4.92. That means you just interchange the probe. Your probe is not correct. Where you think it was positive, it was actually negative that was there. That is clear, share. Is that clear?
Yeah, yeah.
So now the next thing I want to do now is to do something by bringing out those two values using jumper wires. Now I want to bring out those two values from jumper wire now. So I'm plugging these two jumper wire into this male pedal.
Sorry, to get you clear, the 5 volts you're measuring now is what you took from pin, the respective pin of the microcontroller, right? Specific pins. You already connected it to the.
This one is not for microcontroller. It's not really related to microcontroller. What I'm doing now, the question I'm answering is that you jam this maybe somewhere and you don't have access.
No, I get. I mean the 5 volts you're talking about.
So this 5 volts now, I take advantage of 5 volts from my laptop, from my USB laptop. So I just walk around that route to get the 5 volt on this board. You understand? I'm not programming any microcontroller now. I just want to know where will I connect A. You know, it was easier on Pro Tools because A, B, C, you just connect it like that. But look at in a physical sense, nothing was written on it to tell you where A is, where B is. Can you see? So, and it wasn't arranged literally like that. Just take that one from me. When we are looking at data sheet, you will see that also. That this pin was not actually arranged like A, B, C, D in that format, in that order. Did you get it now? So it was missed. So how will I know where will I plug in my A? Where will I plug in my B? Where will I plug in my C? That was what I'm trying to answer now. You understand? Also bringing more perspective to the fact that some are common cathode, some are common anode. You understand? Did you get it now? So I want to give my own way of testing it. So it's just 8 trials. You know we have negative here now on this yellow line now. Let me read it again. So I have negative on yellow line, I have positive on orange line. So just take negative to one of these extreme of the pins here and drag positive across. What did you observe? Can you see? Some light comes on. Okay, let me be doing this. Please, can we all see it?
Yeah, we can see.
So what does this thing tell me? This just told me that this is A, B, C, D. This pin I'm pointing out is the D pin. This is the C pin. Can you see? So this is E pin.
But how do you know now? How do you know from this ABC and this C?
All right. Let's do it again. Can you remember that this is A? This is A.
Okay.
This is
That's
B.
fine.
This is C. This is D. This
Mm,
is E. This is F. And this is G. So if I place something here, that just tell me that that
oh,
one is B. Can you see?
okay.
So if I move like this just tell me that this is F. This is A. Can you see that it wasn't arranged like normal? Did you get it now? That's why I was trying to explain. It wasn't arranged like chronologically. So you have to just do this kind of text if you don't have access to the data pins. You understand? The data sheets of these particular ones. Like, so you won't be able to know where the pins were actually connected. So that's why I want to. That's the whole aim of this explanation. And for the fact that I kept negative at a junction. Did you understand me now? That I kept negative at the junction, at one junction behind like this. See how I'm doing it. The fact that I put negative at this junction and I'm going across like this, I'm finding results. What does that mean? It means that this particular cell segment is common negative, is common. Did you get it now? Because if it has been common positive, I have to put a common positive here and keep going like that with negative. Did you get it now? Is it clear? It's not clear.
Yeah, it's clear.
Okay, good. So that being said, our aim tonight is to actually look into physically run this code using some segment on Atmega 32. This is Atmega 32. That's our aim for tonight, to do this that we did on software yesterday and implement it. But because of the issue we had last night, that our tool was not properly correct, so let's do it again now and sort this out. Let me
But I was
just
thinking that's an assignment you gave us till
okay.
Wednesday. You want to do it?
No, because we didn't get to it properly. But we should use
That's
the
what I'm
number.
saying.
Okay, let's do it
Use
this way.
at
Let's use the
what I
number again.
suggest.
All right, let me know
What I
something.
suggest. What I suggest. Use Atme. Like this suggest use Atme, but don't figure out
No,
which
I
of the
should not
page.
figure
Don't
out
figure
that
that out
solution.
fast.
All right, that's
Just use
fine.
Atme and do it like
And
you
do
did
it like that.
yesterday. Use Atme.
Fine, thank
Yeah.
you. You make my work easy.
We'll do the assignment.
All right. So can
Please hope you
I
agree. Please hope you agree.
peace is agreeing already. He's agreed already. He has agreed since safe. All right,
Uh,
let's go. So if I want to change now, I need to unpin this now. Share. I need to unpin physical, or I can still go on and share my
yes,
screen.
yeah, you can unpin or you can share the screens.
I can share the
Instead,
screen.
it will just unpin myself.
Okay.
Yes.
Thank you, Uncle Peace. We'll get used to all this technology. Don't worry.
Do you want?
So I need to open MP Lab now. MP Lab. Okay. Micro Studio.
Are you using peanut butter milk?
I asked me. I'm sorry. Let's run. Thank you.
You like MPLAB so much, that's why.
It's my favorite. Sorry. Hey. All right, it's coming up. I believe my screen is showing. Is it showing? Is my screen
No.
showing?
To open it.
It's not showing it too.
Can't share screen. And no problem has occurred in sharing screen. Maybe I have to unpin this first, so bro.
Yeah.
Yeah, maybe you should.
Okay. Unpin. Good. By the time I will finish this class, I should be Ogbonge in Zoom. Is it showing now?
Yeah, coming up.
Okay.
Yeah, it's showing.
Good. So I'm trying to run. Don't forget that as we are opening Atme Studio, there are two header files. We call them header files in Atme Studio that are very important. which number one will be generated by Atmos Studio 1. The first one will be generated by Atmos Studio by default. And that's actually include AVI and IO.h. This talks about this will make this like another file that is making Atmos Studio to know exact microcontroller you are using and the pins according to the pins arrangement in the physical ones. So that's what the header file is doing. The second one is the one that MPLAB use a built-in function that does the time calculations for delay analysis that we are talking about. Those two things is very, very necessary. And the next thing is to define the speed at which our microcontroller is going to run with. In our case, I said for almost all these classes, we are not going to be connecting any crystal oscillator, which is 8 megahertz internal crystal oscillator. That's what we'll be using for the purpose of this class. So that being said, we can run that. All right. Okay. Sorry. What's this? All right, so new project. Of course, C executable. Then what should we call it? Let blink 3. Abi? No, 7 segments. Sorry, we have leave let. So there might be a slight change to our class next week. One of my very, very close friends is getting married next week Saturday. So I will be traveling out of my locations from Ile-Ife in Osun State to Kogi State. But whatsoever the changes look like, I will inform us before.
So what classes?
What? You know what those classes? No, I want us to have classes. I want us to have classes.
Okay.
So
Okay.
if I'm going to just change timing, I don't know what I'll meet there. She understand? So that's what I'm just trying to say. I believe everything I've done now is clear to everybody. There is no need of explanation. So AVR dot /IO.h has already been included here by Atmos Studio by itself. So you can just do yourself a favor by just sending this to engineer schedule, for example. Then now there's a warning that happens last time. Let me just show you that one. So when I was teaching last time, because and I said this hash include share. So just go down because of the IntelliSense, go down. Then you just type UTIL, it comes in, then /delay.h. You see. So we had a warning message when we did something like this last time. And the next thing we want to do is to ask divine. Can you remember? Then we said F underscore is already there, CPU operating frequency. Then we put 8 million. And we'll say unsigned. So if I compile this code, for example, now I build this solution. Look at what happens. I just want to teach something. Can you see? He gave a warning and he said F/_CPU, that is operating frequency for the CPU, is not defined, and this particular header file needs it, and he said you will redefine it. Can you see the error? The warning. It wasn't actually an error, it was a warning. So I want to explain why we have this warning and what to be done to fix it. Look at this particular line of code. In this line of code, did you remember I taught something when we were in MPLAB that There's nothing like delay on microcontroller. There's no microcontroller in this one that has delay. You understand? So what happens is that it is IDE that generates a loop, a for loop that calculates the number of no operations that will equivalent to that delay that you are talking about. For instance, we are running on 8 megahertz, which is, and you know that throughput for ATmega32 is, for that 8 megahertz now, is actually 8 million instructions per second. Did you get it now? So if you want 1 second, that means you have to write 8 million instructions in line. So when you say delay for 1 second, what what Atmel Studio does is that it generates internally a for loop that runs for that time. But that loop requires first this parameter. Are you with me? Did you accept with me that if you don't know this parameter, you will not know the number of loop you need to run to get a
Yeah.
non-time? So what this is saying is that when I was trying to evaluate this particular thing, I did not see the frequency, because you know it's a compiler. The difference between a compiler language and an interpreter language is that compiler reads step by step. You understand now? So he read this, but before he can read this, he needs this here. Can you see? So when he gets to this level, he finds that it doesn't have this. He said, one, you need frequency of the operating voltage of the CPU for you to be able to use this function. Can you see? Now you now take a default value. That was the reason why our timing was not correct that time. Do you remember? When we use Atmel, you now use a default value by itself. Later in the day, when you now saw that you put this again, you now say you redefine it. Did you get it now? So redefinition is a problem in programming. Like you have said Segun equals to 13, you now say Segun equals to 12 again. You know you redefine Segun. Did you get it now? So in order to fix this, what you just have to do is to cut this, like,
Bring
and
it
place
before
it
it.
before this guy. Did you get it now? So let's now compile it again and see what happens. Or let's build it again. You see there is no word. Is it clear now? So before we even
Yeah.
move to today's agenda, so we begin again. So which port are we using?
Port A.
Port A. So DDRA equals to 0 x. This
I
time,
have, you know, I have a question. You know, I asked a question last time.
okay,
For port A, there is 6. You know, for port A is 6 bits, right?
okay.
Port A for PIC and also Atmel, right? Is 6
Let's
bits.
check for Atmel.
So
Let
the
us not
when you're
guess.
writing the
Let us not guess. Let me just confirm that. Abi,
all
just
right,
once and for all, let's confirm it. You can see my screen. Let me
okay.
put I don't want to guess because I don't actually have that values in my head. So
I know for PIC is 6 bits, but I'm not sure about Atmel.
myself, I'm not sure. That's the reason. So let's just be sure. Once and for all, so before we move. So this is Atmega 32. Right, so let's go on. Port A here is 8. Can you see?
Is it?
It's 8. So let's just,
Okay.
we should still use it. Share?
So I have yeah, I was using.
Okay.
So for PIC, so I have a question. For PIC, that port A
Alright.
is 6.
Ask your
So
question.
how do you write that?
I will answer you very, very clear. Now, if you can't write it on bit level, on hexadecimal level, the question is what happens if I write it like this? Abi, what happens if I write it like this? She understand? And there are 6 pins there. Now let me tell you what happens. So it will count like this from low significance, 1, 2, 3, 4, 5, 6. You see the remaining 2 bits that are above is lost. She understand now? It's lost. Why? The answer is this. In real sense, there are physical transistors inside microcontroller that store these values, that store this thing that we are talking about, this 111 that we sent now. So because there is no physical circuitry to store it here, so the data got lost along the line. There's nothing to receive it, so it will still not disturb your code. But remember, your working registers, your accumulator, your system, your processor can handle this 8 bits. So by the time it's trying to dump it, the 2 bits that are the most significant 2 bits will just get lost as a result of that. That's the explanation for that.
Okay. So basically, when you're writing it, you make it 8 bits, but it's just,
Yes,
you know that first two is lost.
yes, you just maintain your 8 bit and just go your way. So as normal
Okay.
as what we used to say, we now say port A at this case is equal to what? 0, 0. Sure. Note the difference. Note the difference that in Atme Studio, in Atmega, 1 is used to configure output. In PIC, 0 is used to configure output. That's just the bit difference at this level. As we move forward, I will be telling us the difference between each and individual ones of them. So again, we want to do port A. If anybody could remember, remind me, I will check our table here. So I think the first one is F something. So
FC.
FC, yes.
Zero is FC.
0 is FC. So let's start with that. So I'll quickly do
FC.
something in software, then quickly back to hardware, then we run that way. Okay. So taking back to where I am. FC. So I'll just follow. So let's just do FC first. Okay. 0 times FC.
Check it out, but I'm not sure. Check if
No,
it's FC.
it should be FC. It's correct, FC. Maybe it's just yesterday we did it. That thing is still in my head now. It's not that so far.
This
Because I'm actually using my phone for the camera.
Okay,
I'm
FC.
using my phone for camera.
Oh, it's FC.
So that is why I
Yeah, I just checked. It's FC.
So it's FC. So let's go. So if this is done, that is all we need to do now. There's nothing else. There's nothing else we need to do. So we know that will compile now. There's no need to wait here. So let's come here and put our device. Just to save time. I'm going to do it physically. So that's
Just copy your codes now. Send to me, please.
okay.
Send on a group, brother.
So I have this now. I have my particular. Okay, so then the next pick is to pick 7 segments. 7 is like 7 segments. And we have that. Common capital. That's what we're looking for. CC. Common capital. So this one have decimal points. Let's use so what I could do is to just flip this in horizontal direction by saying, bro, PC, are you the one watching Nigeria movie?
Yes. Not at all. Sorry, my mic. I don't even know my mic was.
Don't challenge my brother.
I'm not watching any movie.
Enjoy your weekend. As our president used to tell us.
This call is about to end anyway, just for you to know.
Okay. You know, this is following one assumption that this is the way ABC was connected. Yeah, sure you get. That's following that
Mm.
assumption. If it is not so, then we'll change it. Because I believe Pro Tools does not have a way of telling us where is A is, where is B is. So then the next thing to do is to just direct this to where our code is. So this time around I'm using internal RC and I'm using 8. Then here so Atmos Studio. Atmos Studio is not difficult to locate. It's under your document. Then we are on 7 segments like this. Then 7 segments and debug. Then we have the X file like that. So this okay. Then run. So that simply means that the connection was wrong. So I'll just stop it. This is
Yeah,
what,
same thing happens with PIC now.
yes. So let's just delete the whole connection. Don't mind them. So that means it was connected wrongly.
Please send the code now, please.
We'll select all these connections now. Select all of them and delete it. So this I'll do Y mirror. Then with this now, should I have to start from? Okay. So that's been done. Then run our code this way. So that means one is still not out, still not connected the way it's supposed to be connected. Okay, what would be this error? FC. Wait, though, it can't be FC. That file is supposed not to be FC now. Please correct me if I'm wrong. Check. Because FC means
I've already checked.
FC means
FC
FFFF 1111. I mean 1100.
is 1111111100. That's FC or 0.
Okay.
I know FC. I don't know. FC was correct for PIC yesterday. What wasn't correct was the number 1 display.
Okay.
It's number 2.
Let's
Number 2
do
display
let's
was
do
not
this one.
correct.
Let's do this. Wait. Let's do this. Let me go to my calculator and bring programmer's calculators out.
Isaac, please send. Let me start doing it here also now, so that
Okay, I'll send this.
we got bugging it together.
Okay.
So debugging it together. I'm
It's
sorry.
okay, no challenge. Okay. 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 So if I do, I'm on hexadecimal and I do FC. FC said that, can you see? FC is saying that
Hmm.
two values will be zero, that two legs will
Mm-hmm.
be off. Can you see? By default, like on a just a simplified version.
Yeah.
So if I go back to Pro Tools and I run it this way, and I run it this way, so and two lights is off, this and this. Can you see? Now something is
So
saying
how do
that
we not do it for PSC?
I am not so sure.
What the PSC error
But I
used to
can
do?
remember it's like FC is what we use, but that's an ISO. That's a very
Let
okay.
me go and check
Okay,
again.
wait. I understand what the
Let
problem
me
is
go
now.
and check.
Remember that it was seven lights.
It was running now.
It was seven lights.
Eh.
Wait. I've lost. The eighth one was the decimal point. And this does not have a decimal point, so by default, I did not start from where I supposed to have started from. I don't know, maybe you get the explanation now. So it has,
Okay, yes, it's
so
true.
it's now correct
Yesterday we didn't put on the eighth one. We didn't
because
put on
there's
the eighth one.
nothing on the 8th by default. The,
Yes,
the
it's
reason
true.
why it seems that it was correct is because it is zero. If it is another number, it will be totally wrong, or obviously wrong. I don't know, maybe you can imagine what I'm saying. If it has been another number,
So this one you're using now has dots now. This segment B you're using now has dots.
it doesn't have dot. It's 7
Dot
and
doesn't have, okay, so it should,
it
okay,
doesn't have dot.
7.
It's 7. So please, I believe you are getting this thing. Can you see now is correct?
One, two.
The two leg that
Yeah.
is off now is the dot and the in
So,
between
so.
one, the one inside.
Mm.
So
Yes, it's true.
that has solved out our problem. So we can just go back here. I believe I don't need to do this. You can just give me, so I can just do underscore delay and I take 1 second here. Then but I believe this should be something around, if I get this, something around 0b 011 000 000 1 2 3 4 5 6 7 8 9. So this is what it should look like for one. Does it look like this is simple
For
for one?
to
Because
display one.
I need to just do BC. I just need to do BC. And if this is BC, it should correct
To display one.
to display one. I just
To but let's say 011 000. What is that?
so
Right.
look at this. This is A. A is 0 of
Okay,
A.
okay, yeah.
BC.
Mm,
So
mm.
let's just check this out again. Double click this.
That code has not sent since. So yeah, the network is not good. Code is sent have not has not delivered.
Okay.
Do you know?
All right. Let me check. It's network. But I sent it immediately. Can you see?
Yeah, I see.
I sent it. It's just network. I don't know how the network is allowing call and it's not allowing message to be sent.
What's
Interesting.
happening is different.
This is Nigeria for us. So let's do it again. We go again. Wow. It's trying to reconnect. Okay. What is this? Okay.
And just leave it. People said I can't copy itself. Ish.
All right. I'll send it. Now, the next thing we want to
Can I
do is
copy it fast?
okay. I should just place it on screen. I mean,
One,
it's
two,
actually simple. This is just a normal problem.
yes, you just copy it. Yeah, it's
DDR
what
A
is page.
equals to 1.
DDR equals to X Y1
Wow. Zoom is saying this call is about to end. This call is about to end. I will generate another link and move again. Okay, that's when they actually cut us off. Hello? Okay. It has ended. only peace we are waiting for now.
Please, I'll be back shortly. I'll be back shortly.
What?
I need to short. I need to restart my system. See, my Atma is giving issues. I forgot to install it on my work PC. I
Oh,
installed it on my laptop, so let me just restart the system.
okay. So,
I'm
all right.
talking
Restart.
about my phone, Sha. I'm close to my phone,
Okay.
so I can hear what you're saying.
All right. I'm just waiting for peace. Peace. Let's just give him like 1 minute. I don't know why it's not here.
àwọn muslim tó wà lórí fóònù wọn fẹ́ kí so wọ́n á lọ sí fídíò status àbí nǹkan kan ṣe láti lọ wo.
All right. Peace is here. I believe. Admit and admit. Okay. So next thing for me now is now let's go physical. So we can do the hardware part. So I'm going to be using this. I'm going to be using this. I think I can share my screen on my phone also. Before I go, I think that will be more fast for me. So let's see. Yeah. Share screen. Continue. Start now. So I just want to take us to my AliExpress cart when I bought this um so I want to look for so I'm trying to search the data sheet for this particular product. Okay, so I was able to get it. So from this diagram now you could have seen that for 7 segment display there are different sizes. Let me just show us parameters that are very important here. Look at this one is 0.5 inches 1 bit common anode. Can you see? So if you click on this now on AliExpress now, you can see the size of I cannot show my picture again. The size of these ones and the size of those smaller ones are different. So that's why you can see 4-bit common cathode. Can you see different options available based on the one you want to buy? You can find that there. So why I open here is what I'm about to just show now. So this diagram is saying you have E, D, DP, CG, H4, and if you go up you have B, H3. Can you see the pin out arrangement for the 4 ohms I bought, 4 bits? So you can see the pin arrangement like that. I'm sending this to our group like that. Okay. So WhatsApp. that has been cleared like that. So A, B, C also well labeled. Okay.
Please let me in. Oh, I'm Isaac.
Okay. Ah, I'm seeing admit entry. Okay. It's okay now, sure. But you are able to follow what I was trying to explain before.
Yeah, yeah. I heard you.
So I just try to, where will I stop this screen sharing here? Stop sharing. So what I'm about to do now is to, I believe, is to pin this to our to. So let me pin potential now for everyone. Then camera on. So okay. So I'm trying to put camera on this time. So is it pin? Pin this to that. So it's showing now. So in this my small board that I designed now, so I've already created a space here for this same segment. You can see these two header here, one here and another one here. So what I have to do here is, did you want me to do it on breadboard so that it should be much more clearer? Let me not use, so it won't be like I'm using cheat. So this is on breadboard now. Remember, this is the right orientation according to that pinout. This is the right orientation. So I'm plugging it like this. Let me shift it a bit forward. It's not the same thing. So now okay. Let's do our connection first before we now upload our code. So can you just look at the WhatsApp and call for me? Okay, let me see if it's showing for me. Yes, it's showing for me here. So I can. So the very first pin here is called E. So let me first of all take out the 8 lines. 1, 2, 1, 2, 3, 4, 5, 6, 7, and 8. Like this. So, and I'm taking an assumption that I'm going, again, port A is around here. So just plug it one by one. So if this is A, B, C, D, E, so this is my E like that. So go straight to this. Cleared. Then the next thing is D. A, B, C, D.
Can you bring the breadboard to the left? Yeah.
It's
Stop
clear right now,
it.
share. So I just plug it to.
Yeah.
So this is D now, followed by D. Then the next one is what? DP. DP is
DP,
8. Is 8.
decimal point.
This is decimal point. Is 8. Then the next one is C. This is black. Let's see. Then the next one is
But you said the first one was what? Is it A or E? What's the first one?
the first one is A. So I started from A, B, C, D, like that.
Is that A? So that's C. But see, I can't see it clearly. I don't know what's showing. It's
No,
blurred.
I'm not
Is that
actually.
A?
I'm not actually my.
A is in A is on the other side
The
though.
very
This
first
one
one
is
is E. The very
either
first
C
one
or E.
is E. E. The first
Okay,
thing
it's
one
E.
is E. Yes. Okay.
Okay.
I now understand the question now. It's E. So, what next? What is my next thing? The next one. So I've finished the one under here. So I have H4. Just leave H4 for now. I've done. Have I done G? G. G.
No, you didn't do G.
So
Count it
G.
now.
So A,
Sorry for
B,
interrupting.
C, D, E, F, G. I'm coming. A, B, C, D, C, D, E, F, G. This is G. E, F, G. So G, 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 G. So G will be here. Then the next one up here. So just leave H4 for now. So if I go up at the other side, I have my B just directly over this place. So B is directly over this place. So I want to turn to the other side. B is like the second pin here. B like this. This is B. Then followed by H3. Then I only have AF there. So if I follow this place also, I will see 1, 2, and F is directly beside A. F is directly beside A, so F is so so with this now, I have all my segments connected. So the question is, what is H1, H2, H3, and H4? I mean, that's the question. Now the answer is H1 is the common negative for this first one. Did you get it now? H2 is the common negative for this second one. H3 is the common negative for this third one. Is it clear now? So that's what H1, H2, H3, and H4. So which one should we use? Which H should we use? Which segment are we trying to on? Anyone. So let me just use H3. That is close beside this guy. Peace. Peace. I need to hear a response from you. I hope we are following. Hope this connection is clear.
Yeah, following, sir.
All right. You have all this setup. Peace. You have all this setup. There is no excuse.
Yes.
You have all
Yes,
this.
I'm going to complete it and send the video.
Okay. So the next thing that I need to do now is to stop this sharing. We have done our connection. This negative, remember this yellow negative I put out that time. So that was what I connected to that H3 already. So then the next thing to do now is to go back to our code. And of course, let me just share my screen. We don't even need to do new code. Okay.
But I only have one breadboard here.
One is okay.
I think you're using two.
Okay, I'm not using two. It's just a professional breadboard I'm using. It's one.
No, it's not professional. Wow.
Don't worry, manage what we have. It will still work. What you have is just like one of this. It's just like this section.
Yeah, I'm just kidding.
It's just like this section. That's what you have. So, now, what I need to do now is to just go back to our code. So let me stop this. I shall unpin this, Abby, so I can share my screen. It's not going to be a long thing, sef. We already have the code. Then on pin, so I need to locate Synapse. That's the very first challenge now. Okay. Come here, I will share my screen 1 minute. I want to open Synapse first.
Sorry, what site did you go to get that picture?
Which one?
What sites?
That I
The
went.
website you went to get that
Okay, I
picture.
went to AliExpress. That's where I bought it from.
Okay,
But
let's close.
I can also do it in another way, which I'm going to do now, so I can get where I can. So it's not a must that it's AliExpress.
How many bits? How many
It's,
bit segments you say
it's 4 bits. It's 4.
Okay, 4 bits.
So another way I can use to notice is, so let me share my screen now. Another way I can use to observe which one and which one is, I'm sharing my screen first. So it actually has a code beside it here. Okay, how can I show that this? So I'll just call the code sharp because I don't know. Okay, which side I need to go side. Okay, this is where my camera is. Okay, there's a code here. So let's try and browse this code. I'll just type it here. I believe this code is supposed to give us. So the code here is HSN hyphen 5643A S hyphen H. You see, you already have it. Let's see what God will bring for us. Why? You can see, and this should give us the this will give me the stuff already. It's opening the PDF, the data sheet of this. So I might also share it with the group. Okay. Very, very quickly, let me compile this code for 0 again. Since it's our duty to figure the remaining out. So let me compile it for 0 again. Good. Build successfully. Okay, so we go to Synapse, and I said the very first thing is to do search. That if 14 is equal and you have connected your things, you can see searching. Okay, that means you have been able to see my microcontroller from there. Then you program the fuse, which is 8-bit internal. Then you do program. I believe I really need to push all these videos to YouTube. I really need to push them. So then I want to program the flash memory now. Then I'll open this. So I know where it is. This time around, I can just go back. It was our last code here. 7 segment, debug, and extract. Enter. So the next thing to do is to do what? Program. So let's see what happens to this. So program has been sent, and I see. Okay, sorry, can you see negative line? Let me pin it back. But this process has been clear now. Stop sharing, and the negative line has removed. That's what I want to actually show us. I want to pin that potential back. So this negative wire, this yellow, has removed like this. So let me return it back. Right, okay. So what does this says? What does this says? And this is what is given to me.
What's that? I don't know what's that. Though.
This is
This
6.
six. Okay.
6. And
That's not. s-
it's supposed to be 0.
Have
So
that top one now.
so let me fix that from code. I just know that I interchange something. So it should be CF.
Sorry. Sorry. That H3 connected to. I thought to say that the first one is from. It's like counting from the left,
I
from
use
the
that
right,
means
or from the left.
that means they are starting.
Use H.
They started counting from here. Let me see where I connected it to. So let me not give any
Use
value.
H. You say H3 now.
H3.
You say using
I'm
H3.
on H3. So they started counting from here. 1, 2, 3. Can you see?
Oh,
1,
from
2,
the
3.
left. Okay, it's
That's
from the
their
right.
standard. Now them sir. So
Alright.
this is the data sheet now. Okay, I'm not even sharing my screen. Sorry. Okay, let's go back. So what I would do to fix this now is to just change that code to CF, not FC, and compile it back. Sorry, I will not share screen because of time. Now I have to still do this again. So I just change it to CF now, then compile. So currently now on Synapse, I'm doing advanced and I'm erasing the chip now. So that's why I just finished doing now. Then I program the fuse back, then go back in there and pick the same segment and drop it here and do program. Wow, this is giving me something else.
Ah.
Okay, I
Uh,
think I have to just fix this. I have to just fix this. I have to just fix this. CF. I just think something if I turn it that way. Hope I did not make mistake in my this. So, well, this is too. That's the difference between simulation and real life, sha. So
that's it though.
that's
That's
just
not
it. So
simulation.
let's just take time and do the right thing. Chip erased. Then close this guy. Program fuse.
Segment.
So then take this to this place, X file, then bring it in. Boom. So program. Now I want to verify. I actually sent. I actually sent 111. So if I follow that, let's share screen. Let's share screen. Oh, okay. So can I share my screen so that I can bring explanations to why this is like this? So
Yeah, share your screen.
let me unprint it. You see, this is hardware. This is hardware, and it's like that. So look at this. When I actually say FC, so what I did there was to write 1111100. It's an arrangement problem. What we're having now is an arrangement problem. You understand? So why I take my time to just look into this and fix it. So this, what I'm trying to evaluate now, is to check where does this one start from. 1 1 1 1 1 like this, then 1 1 0 0, or is 1 1 1 1 from here. You understand what I mean now? 0 0 down. Is it the downside? Is it between 6 and 7 that we have the 0 0, or 1 and 0 that we have the 0 0? That's so the easiest way to get that answer is to look at port registers. I mean, that's where the answer is. And I think that should be on page 140 something. If I did not get, because that time I was teaching it. Okay, this is taking me more than what I expected. Do it. Or is it page 64? I think it's 64. I think I saw it on 64. So, 6 5. Let's check. Yeah. That's interesting. So it is, we wrote 1 1 1 1. Do you see the way the register was arranged? So 7 comes first. So 1 1. But while we are arranging it here, we put 0 first. This is 0 first now. So this jumper wire now is supposed to have been returned in reverse. Did you get it now? So again, let's look at it. This is my, so I call this A. You understand? But remember, this is PA0. Let's check again. Home page. So this page is page 65. This is it. Can you see this is O now? This is port A0. So it was arranged from here to here, but I connect from here to here. Can you see? That's the difference. So I'm just going to remove this like this, then turn it like this. Can be a bit stressful this way, but I want to be sure that I did not jump in. So can you see it's already correct? Is it clear? Did you understand what?
So basically, you just switched it,
Yes, I just figured
right?
it. Yes, because what I wrote and what I connect was in reverse. Like I take this bit from up to down, then they take it from down to up.
Got up. So
Adding
now
in this
for this
place is
zero,
what? Yes.
for
Adding,
zero,
mhm.
it is 0 0 is for port 0 and port 1 of the port A. 0 and 0 will go to port 0 and port 1. Then the rest are ones.
Yes.
That's what you mean.
I also want to do something. I think I want to use my book and Bible to explain this, so it's more clear. So let me do this. So okay, I wasn't even sharing my screen before. Okay, I was sharing. Stop sharing. I want to print this guy. Print this guy. So I want it to be very big before I start. So if look at this, this is my microcontroller now. So I have PA0 here, PA1, PA2, PA3, PA4, PA5, PA6, PA7. Now the way the register was arranged was that here we start with what? PA7, PA6, PA5, PA4, PA3, PA2, PA1, and PA0. So once when I wrote FC, this is how the register received it: 11111110. Did you get it now?
Yeah.
In this
Mm.
manner, that A is here, B is here, C is here, D is here, E is here, F is here, G is here, and decimal point is here. Because it is then that we can have 0 here. Look at what I now went to go and connect. I now connect A, B, C, D, E, F, G, H, G, D, P. Did you see that? This is just totally against this. PAO should have connect DP. Can you see? PAO, what's supposed to be on PAO should have been DP, but I put A there.
Mm.
Did you see the error? So what I did was to reverse it and put DP, G, F, E, D, C, B, and A. So I just reversed the arrangement to match how the register is arranged. Can you see?
Yeah.
Is it clear now why that was not correct? And that is that. Uncle Peace, question. So should we try another number? So let me just do maybe, which one should I do? 6. Give me another number so that we just write it on the code and we upload it. Since we are doing 0 to 9 in this class as an assignment. So I can do 3 numbers. So let me try and write something that is not number. Let me write alphabet C. Abi? Letter C.
Okay.
So let's analyze it. So this is my 7-segment display. And this is my C. Shape. So that means I'm owning A. I'm owning A, B, C, D. I'm owning D. I'm owning E. I'm owning F. That's all. Shape. If I interpret that to this table, that means 1, 0, 0, 1, shape, then E, 1, 1, D is 0, and D is 0. So I have 1, 0, 1, and this is 9. Shape, 1, 0, 1, this is 8, this is 9. I mean, 101 is 9. Then 1100, this is what? 1100 is 8 plus 4, that's 12. 10 is A, B, C, 9, C. Of course, you can still use your calculator to do that. So if I'm on binary and I clear this, so I have 1001, then 1100. And that is 9C. So, correct. So then we move to programming. Should I share my screen or I should just upload it?
Upload it. You can check and upload as well.
So nice. So let me just compile it again. So what I'm doing now is I'm going to Snap Program Advanced and I'm correct erasing my chip. That's why you see it off. Now the next thing is I'm programming diffuse. Just program diffuse now. Then I'm going to self segment the one I just compiled now. Then put it in there. Then program it. Can you see? Letter C.
Mm.
So
Mm. So, but you can actually write multiple, like a word instead of
yes,
a
you can
letter.
actually write Shegun. You can actually write your name. You can actually
Oh.
write car for this four. You know this one is four. That's why they make some four, some six. You can combine
Mm.
two four. So
Mm.
So,
I, I'll be teaching that mystery. I will teach that mystery in this class. How are we going to be able to do it? It's a very serious mystery because the question is for you to write car like a car. That's C-A-R. Abi? That means this must write C, this must write A, this must write R. But all of them share the same data line. Let me show you what I mean by that. You know this is segment 3. I can
Yeah.
on second segment. Can you see?
Yes, sir.
I just change A.
mm,
Then I can on this last one. I just change this. Then I can
So,
come and on
so
this last one.
you have to use three different data lines to write car.
So how will I write something different here and something different here when they are sharing the same data line? I will teach it.
Uh,
That's the question, Abi. I will teach
yes.
it and I will do it in this class. The mystery around it.
Are you doing it now?
No. It's late now.
Okay.
It's actually come multiplex. It's done via code. It's coding. It's not even hard. It's coding. So
Okay.
uh let me I believe there's no questions for tonight. Let's give it a try. Let's do our assignment finish so that we get used to this. Then over the weekend I believe we will do this. But I will still be doing it on Atme Studio because I'm be traveling and to just carry this small gadget now with me is easier than say I want to, you know, PIC is bulky. So PIC is bulky, so I will just use this. But that day I might be using this. You see, I've already configured this so that this one just come in like this and sit. Can you see? I've already
Yeah.
designed my board like that. I can use it to this. So I'll just run my jumper. The work is done that way. So on in this next week I'll be teaching how to write two different values using the same data line and we'll just run that way. All right. Questions and
sorry, I
concept.
was trying to run this stuff on Pro Tools, so I don't know. It's giving me crazy values. I don't know what I did wrong. Can I share my screen?
Share. Let me stop sharing. Okay, I have to unpin this. Sorry. What I have to do is unpin this. Then go ahead and share.
Alright. Although I use a different segment, but it should be the same thing now. It's common cathode.
Of course.
It's common arm.
Common anode, it will be different, man. It's common cathode that you're supposed to choose.
I use common cathode, that's what I'm saying. I
Oh,
use
all right.
common.
So if it's common cathode, let's go.
What is it showing?
It's about to show. Now it's showing.
What is it showing?
It's showing Protus.
Okay. So I connected this guy. I used like from here to 15 stay away now.
Good. I like that. That's sharp enough.
So as in
No,
this
no,
thing
no,
just
no.
anyhow I swear yeah
Okay.
it's good now.
I think
So,
All right. Okay.
then
The code is already there. Is the code there?
yeah, I already uploaded the code.
Okay.
So this first one is not
All
it's
right.
not turning on. I don't know why. And this middle one is turning on. When it's not, it shouldn't be turning on because we're not running.
Okay.
But the
Stop.
code is what safe.
Check what the
But
code
the
is.
code is to run. The code is to display 0 and delay and display 1, right?
Okay.
But it's not even blinking. It's
Okay.
just showing.
Let's do it this way. After that delay, clear the port. Like turn off the plot. But let's go back to Atmos Studio.
At me.
So that means after the delay, when I'm writing port A equals to 000,
Oh, I suppose.
port
Clear
A
it.
equal to 0x00, comma, then delay again. Put delay in between. So build, let's go.
Okay.
Yes. So go to, we'll stop your simulation first. Then double click. 357. Is it in the afternoon? Are we in the afternoon?
Yeah, I love to.
Okay, let's play.
So
That's it now.
no, what's it showing?
Is it the same thing that
You
was
just
repeated? Let me see the code again. But it's offing it and it's on it back.
it's offing it,
Yes, it's
but
offing
it's
it now.
offing it and
Bring
you should
in
off
the
it
same.
and display 1, not display 0 again. Off it and display 1.
Wait. Let's
This
see.
code is
Let's
for
see your one. Check whether your one is
this.
correct.
It's your code, so it's my code actually. It's your one.
Well, it's too tiny for my eyes to see. That's it. You know, it was
It should
zero
be.
B.
Yeah, it's 0B011. Then the remaining bits are 0. So 011, then zeros. That's what this one is. And
Okay,
that's one now.
let's turn that to 60. That's 0x60.
2, 3, 4.
Like let's just put it in Excel.
0x.
60. This time around, use build and clean. The second one beside build. Yes. Build this. Build successfully. We can go to.
Why is it not writing?
It's done.
I can't say hex file. Okay.
Stop this simulation first.
Keep quiet. Yeah, it's no.
Let's see. Well,
The 0 is not even. I think this my
I think
LED
the
is
connection is
even
wrong
anyhow.
itself. The connection is wrong.
The 0 is not
Not even
showing.
showing.
This
So
first
let's
part.
fix the connection first.
Yeah,
Stop it. Let's fix this. So maybe we should shift this up. Like
which one?
maybe we should shift these connections up.
Start from A0.
Start from A0. No, it's supposed to start from
Yeah,
A7.
I already. That's it now. I already did that. It was
Then let's do the mirror of
time.
this guy. Something is still wrong. You know, we don't have access to ABC here. I think we have access to ABC here. We have know how the best way to connect this.
Because this is a different. Let me choose the same LED, the same segment that you chose. That's the issue. Or it's gonna waste time.
No, go
What's
ahead.
the name of the segment?
I don't know the name, but let me find it for you. Yeah.
But it's right. This meeting also end now. Common cathode.
Common cathode.
Yeah, I chose this one. I think you chose red. This one, right? Red is more visible.
Common cathode red. Yes.
This one.
I'm trying to come back to Zoom now. I'm actually confirming. Yes, okay. This is the one I chose. Good, 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 good. You can actually connect it from there. Nothing will happen. Okay.
Ah, why is not on it now?
Common anode. You select common anode, Anthony. I can see it
Ah,
from here.
oh, what? Serious.
All right, we still have 14 more minutes. Let's try. Once Zoom end this class, the class has ended.
Wow.
No challenge.
Common cattle
Good. Red.
red.
Yes.
It's cattle now, right?
Yes.
Check.
It's
Oh.
yes. 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 It's only please I have not shared the screen in this class. We'll catch this one day.
No, yeah. No, it's a guru now. It doesn't share screen. Really knows what it's not simple things for him. Ah,
X mirror.
okay.
Yes.
This thing will not do well now. See you. Short. I don't have strength.
This thing do well.
See now, it's not connecting anyhow.
Yeah, that's the
Not
problem.
connecting anyhow now.
And don't worry, once we get to PCB design, you will know why it is. It's called grid line problem. I think this is grid line problem. When the person that designed this schematic and doesn't consider the standard grid line. So there's no way you want to use
Yeah, so it's
zero,
okay. Why is not blinking one now?
0 and 0 and 0 and 0.
Only zero.
What
Only
is-
zero that is doing. It's not.
Oh yeah.
The code
go
is
back-
saying.
Go back to your
The,
code. Don't
the
worry.
code
don't
is
worry.
saying.
Take one first and
Display
bring
zero.
zeros down. You understand? Do one first and bring
Eh?
zero. Like do one first and bring 0 down. You understand what I mean?
Yes.
This problem.
Oh, what's time? 40.
Oh, no, this call, that was the problem.
Showing one now. I did not that
And it's not
showing
showing
one
0.
before.
And it's now not showing 0.
Yeah, it's not showing the second. So it's not showing the second line. After
Line.
this,
After this very first
after
line.
opening it, it doesn't show these other parts. Why?
Alright. I'll look into that. I'll look into it. Then I'll drop the answer on the group. I remember I have this issue when I run one code like that. Whatsoever I did that time, I will remember. But I remember I've come across this error before. And there's something I did that fixed the problem.
I was supposed to put this off. I was supposed to put this guy here. I was thinking, even if you don't, let me try and see.
Just try and do all your bottom and see.
I'm supposed to put this guy here. Let me see. It's going better. Oh, 405. Okay. Ah, yes, he's doing now. Locking now.
Okay.
So that stop should not be there.
That which one? The off. Have you?
Yeah, that off. It should not be there. So you just delay, then put
So you already
zero,
know with
then
your
delay.
assignment now. Just do the 0129. But that
Eh,
one
now.
all right. Okay, that's been a very good way to end today's class. It's already 10 minutes. So,
Uh,
please, questions, question, and question, and question.
oh Lord, thank you for. Let me stop sharing.
Okay, all right. So that is nice. We are good to go.
Alright, good night.
All right. Good night, everybody. Uncle, please. Let's see your
Yeah.
assignments. All right. Good night.